Hi everybody, I'm back with part 3 of the solutions and video for the Unit 5 practice test preparation for this time exponential and logarithmic equations and solving those. So let's get started here. We'll start off a little bit easy and we'll work our way up to some more challenging questions over the next 2 pages. So I am on page 27 down here of 41. And I'm going to start off with number 1. 2 to the what is 64. This does not need a calculator, but we're going to use the same base. If you know it in your head, that's fine. If you don't, here's how it would look. 2 to the x equals 2 to the what? Well, 2, that ends up being 2 to the 6, I believe. And so x equals 6. I'm going to use getting the base to be the same on each side and then evaluating the exponents. So 2 to the 2x minus 1, I want to get 32 to the, it's 2 to the what? So that would be 2 to the 2x minus 1 equals 2 to the 5th. So 2x minus 1 equals 5. If I add 1 to both sides, I get that 2x, over here, 2x equals 6, so x equals 3. In number 32, now I've got, number 3, I've got 32, which is 2 to the 5th equals 8. Sorry, 2 to the x, excuse me. Let me start over. I went into this one too fast. Let's start over. 32 to the x equals 8. I don't have similar bases, so let's go with the easy one first. 8 can be written as 2 to the 3. 32 can be written as 2 to the 5th, and then that is 2 the x. So now I can say 5x equals 3. And x is going to be equal to 3/5. In the next one here, they're getting progressively more difficult. Progressively more difficult here. We've got 3 raised to the 1 minus x is equal to, I'm going to rewrite 1 over 27 as 3 to the negative 3. Now I can set the exponents equal, and negative x is equal to negative 4, so that means that x is equal to 4. Here we go with 4 to the x and 1 over the square root of 2. Though 1 over the square root of 2 is not written correctly, we're going to change that really quickly here by writing the left-hand side as 2 squared times x, and then rewriting 1 over the square root of 2. Let's see, that would be 2 to the negative 1/2. Right? The square root of 2 is 2 to the 1/2, and then flipping that over, making the reciprocal with the negative exponent. So I can set 2x equal to negative 1/2. I can multiply both sides. Well, I can divide both sides by 2. And if I divide 1/2 by 2, then I get negative 4. But that doesn't look right. Let's see. It's the same thing. If I divide 1/2 by 2, yes, I get negative, 1/4. That looks right, negative 1/4. Okay, now in number 6, I've got a base of e. No big deal. E is the natural base, so I'm going to undo a natural base at some point, probably with a natural log. But if that's not the case in these problems, I might just have to raise both sides to the same power and then set the exponents equal. I'll probably have to use the natural log in the following problems. In fact, I know I will. So here we are with e to the x plus 1 equals 1 over e. Again, e to the x plus 1 equals e to the negative 1. I've got the bases on the left and right to be the same, and now I'm going to set the exponents equal to each other. So that means that x equals negative 2. Okay, now e to the x equals 5.7. I'm going to express the solution in terms of logarithms and then use a calculator to solve. So I know that to undo an exponential function with a natural base, I'm going to use the natural log. So I'm taking x times the natural log of e equals the natural log of 5.7. Well, the natural log of e cancels to 1, so x is equal to the natural log of 5.7, which ends up being a decimal, a number on your calculator. And you can crunch that number. In number 8, I'm going to divide by 5 first and try to make my life simple by getting e to the x on one side and then this number 23 over 5. Some decimal. Now I can take the x out in front, take the natural log of both sides. The natural log of e cancels to 1, and I can take the natural log of 23 over 5. That equals x. In number 9, there's not a whole lot I can do here, but what I am going to do is swing down the 1 minus 5x, take the natural log of both sides. So there wasn't much of a precursor to this problem, because when I take the natural log of both sides, the power swings down in front, the ln e cancels to 1. Now I've got some number, natural log of 793, is equal to 1 minus 5x. I'm going to subtract 1 from both sides. Again, natural log of 793 is just a number on your calculator. And then I'm going to divide that whole thing by negative 5 and solve for x. In this last one, I don't know how to get 7 and 410 to a same base. I'm not going to spend time trying to raise 7 to different numbers to see if I can get to 410. I'm just going to go x plus 2. I'm going to log both sides, log 7. And again, that becomes multiplication times log 7 equals a log of 410. Now it's a calculator problem. Whatever the log of 7 is, I'm going to take x plus 2. I'm going to divide both sides by the log of 7. Log 410 divided by log 7. And then at the end of that, I'm going to subtract 2 from both sides. So x is going to equal the log of 410 divided by the log of 7 minus 2.